We're working on the worksheet today called Rent Me. Okay? At the beach in Galveston, you decide to rent an umbrella from Bella's Beach Shop. Upon asking for the cost to rent the umbrella for 8 hours, Bella pulls out a worn and wet table of prices. Oh no, what will I do? Wondered Bella. I was trying to act like Bella from Twilight. Did I do a good job? Like no emotion. Okay, good. Help Bella reproduce the price list. What linear function rule can you use? So the first thing I want you to do is look at this wet and worn table of prices. And I don't want you to speak. I just want you to look at this and see if you can figure out, first of all, what linear function rule, because that's what it asks you for. See if you can figure out how to find the function rule. Now, what I see from looking around the room, several of you have done this. And what you need to understand is that makes me very happy. Some of you drew it like it was rounder. That's also fine. Okay? What? I can see him. What are you doing when you drew these lines? You're subtracting? Why would you do that? You need to find the difference, okay? And what did you get as the difference? $2.25? Okay, 2.25. 2 and 25 cents. 2 and 25 hundredths, right? All those are the same. Okay? So if we care about the difference of the cost, what else do we have to care about? The difference of the time? For any particular ones, like from here to here? Or from the same ones? From the same ones. Okay? What is the difference there? What's this difference? So what can I do with those differences? What good is it to know? What do you want to do? So you want to divide the difference of the cost by the difference of the time? Is that what you're saying? Why would you think it's wrong? Just because you said it? Yeah, that's not okay. You got to be confident in what you're saying. You're right. Of course that's what you meant. Okay? Why is that right, though? What are we doing? I know what you're saying, but that's the wrong word. You're finding the change, right? Aren't you finding the change? What is 2.25 or $2.25 or 2 and 25 hundredths divided by 3? 0.75. So that means if I started at $14.50 and subtracted 0.75, I should be able to get this one, right? What is that? $13.75? So if I subtracted, wait, is that right? Yeah, if I subtracted 75 cents, $13. If I subtracted, oh my goodness, it's right. Right? So what do I know? I know that, right? That's all I know. Is that my function rule? What part of the function rule is that? The one right before x, what does that mean to you? The multiplier? So that's thinking back to last week when we talked about the different values and what they meant. What do you think? Nope, not yet. I'm asking for what part of the function rule is this? Isn't that our rate? Right? Our rate, okay? So in order to create a function rule, what else do I have to know besides the rate? The starting point. How am I going to figure out the starting point? Figure out where I started. Good. Okay, how am I going to do that? Subtract some more. Subtract 0.75 or 75 cents, and I get to 11.50. Subtract 0.75 and get to 10.75. Why? Why would it be 10? There's no more space on the table. That's at 1 hour. When do I have to go back to? To 0, right? 0 hours. Well, why is that not on the table, guys? You honestly think Bella is going to have a list of all the prices, and you think people are going to come up to her and say, I would like to rent an umbrella for 0 hours? That's not going to happen, is it? She doesn't have to have that on her table. She doesn't need it on our table, but we need it on ours so that we're able to produce the function rule, don't we? Okay, so now do I have enough information to produce the function rule? So tell me what the function rule is. So f of x equals, what'd you say? 10 plus 0.75x. Is everybody clear why this is not 10.75? 10.75 is when time is 1 hour. We need time is 0 hours, and that's when it's 10. That's my starting point. Okay, so what can we call this 0.75? We can call it the rate. What else can we call it? Cost per hour. Can we call it the slope? Can we call it the multiplier? Can we call it the constant change? So a lot of the problems come on problems like this because you don't know what to call it. And guess why? Because it has so many different names. Okay? So I'm trying to bring those to the forefront so you can see all the things that it might be called. Okay? Ella's Aquatics rents umbrellas for a flat rate of $16 for the day. So it doesn't matter how long you have the umbrella, it's $16, period. If you want to spend 10 hours at the beach, from whom should you rent? What? Why? So how are we going to answer the question? I would choose who? Ella? Because? Whoa, whoa, whoa. We're not asking about 8. We're asking about 10. Not asking about 8. I'm asking about 10. I would choose Ella because it's cheaper. Okay? Any questions? Don't try to make it too difficult. Just answer the question that's being asked. What about B? If you want to rent for just a few hours, from whom should you rent? How do I start it? I would choose who? Bella. Because it's cheaper. What is the break-even point? Think about it for just a second before you answer out loud. Yes, sir. What you got? 8? 8 what? $8? 8 hours. How do you know it's 8 hours? What's 16? At Ella's? Because it says 16? How do you know it's 16 at 8 hours on this? We can't read it. You can put it in the function rule. If we put it in the function rule, what's 8 times 0.75? $6 plus 10? Does anyone know what 6 plus 10 is? Excellent, 16. How else could you know at 8 it's 16? If I added 75 cents to here, I would get $15.25. And if I added 75 more cents here, I would get 16. Correct? So what is the break-even point? Answer the question that's being asked. The break-even point is what? What is the break-even point? $16. What? At 8 hours. Very good. How do you know? The price is equal at 8 hours for both Ella and Bella. How else could we say it? We looked at the table, and at 8 hours we figured that the cost was $16. How else did you say it? We substituted 8 in for the function rule and got $16. Any of those are acceptable, but you have to justify your answer. Complete sentence, proper spelling, proper grammar, proper punctuation. Please get it done. So we need to make some generalizations. We need to be able to talk in general about things that happen here. Okay? Let's give ourselves some points to talk about. Okay? Let's talk about this point here. And let's talk about this point here. Okay? You got those 2 points? Yes or no? So rude. So rude. Okay. What are those, what's this point called right here? Please don't say Bob. That's what they said earlier. Jorge doesn't work either. What's the name of this point? Do you know that that point is called 1.5? My fear is that you call that point 5.1. Because there are people that think that point is called 5.1. And I understand their confusion, but we really, really have to get past it. So let me talk real quick. Well, actually, we're going to talk as we go through this problem where the confusion comes from and what we have to do to stop it. Okay? What's this point called? 4.8. Okay? So how are we going to find the rate of change between these 2 points? Rise over run has been the most popular first statement by everyone today. And I think that was probably beat into your head in Algebra 1. Okay? And there comes to a point in time, as with all of your classes, where we have to take our vocabulary and we have to grow some. Okay? You understand rise over run, correct? From here, we have to count up or down. In this case, up 3. And then I have to count right. And in this case, 3. Left or right, but in this case, right, correct? So I rose 3 and I ran 3, which gives me a rate of change of 1. Right? And I can prove that just to make sure by rising 1 and running 1. Rising and running 1. Rising, yep, that's right. Because we get back to that other point. Okay? But the thing that I need you to be familiar with is this. Kind of looks like a triangle, yes? Except I'm not drawing a triangle, I'm drawing the the Greek letter delta. And the Greek letter delta we let stand for what? Do you know? Change. And we let it stand for change in not just our math classes, but where else? Science. Okay? So we need to understand that. We need to be able to get past rise over run. We need to understand that that's what's happening, but we need to be able to talk about delta y divided by delta x. Because what we're talking about here is the change in the y values divided by the change in the x values. But guys, isn't in the end the change in the y values how much you rise? And the change in the x values how much you run? So it means the same thing. This is a little higher level. And that's where we need to get to. That's where we need to be. Okay? So we're talking about our change in our y's. We're seeing how far up or down we go. And our change in our x's, how far left or right we go. Guess what we're still getting as our answer? Change in our y's is from 5 to 8. That's a change of 3. Right? A change from 1 to 4, that's a change of 3. Guess what we get for our rate of change? The same exact thing as when we talked about rise over run. Okay? So for this particular graph, how do we find our y-intercept? If we know we went up 1, right 1, up 1, right 1, up 1, right 1, from here, what could I do? Down 1, left 1? Will that still be along that same linear function, that same line? So what did we do? We have to walk back. Okay? We walked back from our 2 points to get to our y-intercept, and in this particular case, our y-intercept is where? 0, 4. Thank you. Any questions about that? Okay, so how is this graph different from the graph we just looked at? Doesn't have specific points like intersections, right? Like here or here. It doesn't have intersections. It's a very general graph. Can we talk about rate of change and y-intercept the same way? Maybe, right? How are we going to talk about rate of change? Change in y's divided by change in x's. We can still do that, right? This time it has to look a little different, though. Excuse me, a little different. What are we talking about when we talk about the change in the y's? What operation are we talking about? Say it. Say it. What operation are we talking about? Difference. Yeah, absolutely. Okay? So if we're finding the difference between the y's, what are my y values? What's my y value here? Y sub 1. What's my y value here? Y sub 2. So if we're finding the difference of those, can I write this? Is that the difference of those? And if I'm trying to find the difference of the x's, x sub 1 minus, x sub 2. Now, here's the thing about this formula, okay? On the formula chart you've seen for years, it's always said this, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Why do we have to start with the second point? I don't know either. I really don't know either. If we start with the first y value and subtract the second y value, why can't we start with the first x value and subtract the second x value? We can. Okay? But if I start with the second y value and subtract the first y value, then I have to start with the second x value and subtract the first x value. Does that make sense? I can't mix them. I can't start y sub 2 minus y sub 1 over x sub 1 minus x sub 2. I can't do that. I can't mix them. If I start with the first point, I start with the first point for the y and the x. If I start with the second point, I start with the second point with the y and the x. This is the quote-unquote formula for rate of change, or the formula for slope that you might see in a textbook or in a formula chart. But really, what we're finding is the change in the y's divided by the change in the x's. Okay? Up here we counted. Down here we can do subtraction. But do you see that they're the same? Okay? How about y-intercept? Can we walk back this time? There's nothing to walk, right? There's no intersections. There's no points of intersection here for me to walk. So I have to do something else. Do you know this? Have you seen that before? What's that called? Slope-intercept form? You remember that? Now, in slope-intercept, remember to find my y-intercept, I can substitute in values for x and y. Do I know any values for x and y? I know two of them, right? I know this one and I know this one. So choose one. First of all, does it matter? So second of all, choose one. First one or second one? Second one. So if we're using this point right here, what y value do I know from this point? Y sub 2. I may or may not know my how I move in my table or my slope, but I could put it in there if I needed to, yes? And if we're solving for the intercept, I will eventually need that, won't I? Do I know an x value from this point? Times x sub 2 plus b. Guys, if I'm trying to solve for my y-intercept, if I'm trying to figure out my y-intercept, how do I get it alone? Subtract m times x sub 2. If I subtract it from this side, I also have to subtract it from this side. mx sub 2 minus mx sub 2 is 0. So on the right hand side I just have b equals, and on the left hand side I have y sub 2 minus m times x sub 2. All this is just like solving for b, getting the b alone. Okay? Any questions about this? Both your generalizing worksheet we just did and the Rent Me both go in your notes section. Okay? Get both of those in your notes section, please.